Hello conservers. Today we walk through the blockchain facts part 2. In Bitcoin, your transaction is sent to a memory pool, where it is stored and queued until a miner picks it up. Once it is entered into a block and the block fills up with transactions, it is closed, and the mining begins. Every node in the network proposes its own blocks in this way because they all choose different transactions. Each works on their own blocks, trying to find a solution to the difficulty target, using the nonce, short for number used once. The nonce value is a field in the block header that is changeable, and its value incrementally increases every attempt. Every miner starts with a nonce of 0. If the resulting hash isn't equal to or less than the target hash, a value of 1 is added to the nonce, a new hash is generated, and so on. The nonce rolls over about every 4.5 billion attempts, which takes less than 1 second, and uses another value called the extra nonce as an additional counter. This continues until a miner generates a valid hash, winning the race and receiving the reward. Fast fact: generating these hashes until a specific value is found is the proof of work you hear so much about. It proves the miner did the work. The amount of work it takes to validate the hash is why the Bitcoin network consumes so much computational power and energy. Once a block is closed, a transaction is complete. However, the block is not considered to be confirmed until 5 other blocks have been validated. Confirmation takes the network about 1 hour to complete because it averages just under 10 minutes per block. The first block with your transaction and 5 following blocks multiplied by 10 equals 60 minutes. Not all blockchains follow this process. For instance, the Ethereum network randomly chooses one validator from all users with Ether staked to validate blocks, which are then confirmed by the network. This is much faster and less energy intensive than Bitcoin's process. Key takeaways: blockchain is a type of shared database that differs from a typical database in the way it stores information. Blockchains store data in blocks linked together via cryptography. Different types of information can be stored on a blockchain, but the most common use for transactions has been as a ledger. In Bitcoin's case, the blockchain is decentralized, so no single person or group has control. Instead, all users collectively retain control.